We know that we can use an LDR's changing resistance with brightness to trip a switch and turn an outside light on or off, and a thermistor's changing resistance with temperature to turn your heating on or off. So far, we haven't said exactly how the sensing circuit knows what the resistance is, and it's this we're going to look at in a bit more detail now. The secret to both is to use what's called a potential divider. The simplest potential divider is just two resistors in series connected across a known potential difference, in this case 12 volts. The potential difference is divided or shared between the two resistances. If the two resistances are equal, then each gets half the potential difference. If they're not equal, then the smaller resistance gets the smaller share. In this example, the total resistance is 4 ohms, so the bottom resistance is 1/4 of the total resistance, so it must have 1/4 of the total PD, which is 3 volts. The remaining 9 volts must drop across the top resistance. With the light sensing circuit, we use the idea that the PD across the LDR must be the same as the PD across the switch hidden in the grey box. If the PD is 6 volts or greater, then the switch is closed and the outside light is on. When it's light in the afternoon, the LDR has a low resistance. So here, it only takes 1/3 of the PD, which is 4 volts, not enough to trip the switch. As it gets darker, the resistance of the LDR increases, and it gets a bigger share of the PD. Eventually, the PD across it hits 6 volts, and the outside light switches on. When it's completely dark, the resistance of the LDR is even higher, and it takes an even bigger share of the PD, and the switch stays closed. The thermistor and the thermostat works in a similar way. When it's warm, the resistance is low. It takes a small share of the PD, and the PD across the switch isn't high enough to trip it. As it gets cooler, the resistance of the thermistor increases, it gets a bigger share of the PD, and eventually it's enough to trip the switch and turn the heating on.